Hello, and welcome to another session of extra problems for quantitative reasoning. This is going to be all about lesson 1.7 over portion control. And I'm going to go through the did you get it for this lesson. It's all about apportionment. And so the did you get it starts on page 109. You're going to want to take and rewrite this table. So I recreated my table. The only thing I don't have is my total, which was, it's a city that has 7 districts and a total population of 960,000. And it says that it's a county here, a population of 7 districts and a county. The county assembly has 30 seats that are to be allocated according to the population of each district. Find the standard divisor. So we're going to remember that the standard divisor is the total population divided by the number of seats. So I'm going to do that down here, but I can space up above for everything else. So standard divisor. This is on page 108 as the formula, and it is total population divided by number of seats. And because these are all in thousands, I can just use the total, which is 960,000. I can just say 960 divided by the 30 seats. And that means we'll get a standard divisor of 32, which means 32,000 citizens per 1 seat. So that's what that means. Okay. Now the next did you get it is on the bottom of page 110, and it says find the standard quota for each of the districts in the did you get it 1. So the standard quota, remember, for all of the did you get it, the answers are at the end of the lesson in this portfolio section, and they're all right here. I'm working through the problem so that you can see how they are found. So standard quota, I'm going to remind you that standard quota is by taking the population of each district and dividing by the standard divisor. So if we take 125,000 and divide by the 32, we will get 3.91 if we round appropriately to 2 decimal places. And then if we, for the next one, if we take 89 and divide by 89 and divide by 32 for the, what we calculated down here, the 32 is their standard divisor, 89 divided by 32, and we're going to get 2.78. And then for district 3, we'll get 7.34. They're the biggest district. And then district 4 is 3.03. District 5 is 3.19. District 6 is 4.0 even. And district 7 is 5.75. Then did you get it? Number 3 said find the upper and lower quotas for each of the districts. So I'm going to do the lower and the upper, just like it was in the lesson. So the lower is rounding each of them down to the nearest whole number. So that's just 3, 2, 7, 3, 3, 4, and 5. Rounding up, the upper is just taking the standard quotas and rounding up to the next whole number. So 4, 3, 8, 4, 4, 5, and 6. And notice that the upper is exactly 1 larger than each of the lowers. Now, did you get it? 4 says use Hamilton's method to apportion the seats for the districts. So remembering that Hamilton's method is going by the decimal part. So we're first going to add the lowers. The lowers are 3 plus 2 plus 7 plus 3 plus 3 plus 4 plus 5. So they add up to be 27. So 27, so because we have 30 seats, we have 3 extras to give out. So Hamilton's method, I'm just going to put Hamilton's here, so I'll fill in what I'm getting. So Hamilton's goes the 3 extra seats because we have 27. The 3 extra seats are going to go by the largest decimal part. So the largest one would be this 0.91. So that means District 1 gets its upper quota. And then the next one would be 0.78. So that would be District 2. They're going to get their upper right here. And then the next one is going to be the 5.75 over here for District 7. They're going to get their upper, which is 6. So that means everybody else is going to get their lower. So District 3 will get its lower, District 4 will get its lower, District 5 will get its lower, and District 6 will get its lower. So if we add them up, we have 4 plus 3 is 7 plus 7 is 14, plus 3 is 17, plus 3 is 20, plus 4 is 24, plus 6 is 30. So it equals 30. Then the next Did You Get It is on page 115. And it says, use Jefferson's and Webster's methods to apportion the seats for the districts and Did You Get It 1. So I'm only going to use Jefferson's because I'm only assessing you over Hamilton's and Jefferson's. So Jefferson's goes by changing the standard divisor. So because we had extra seats to give from the lowers, we are going to increase our standard divisor. I'm sorry, we're going to decrease our standard divisor so that numbers will round up. So I'm gonna try 31. So this is Jefferson's. So I'm gonna try standard divisor of 31 and see what we get. So if we do 25 divided by 31, and 2.87, 7.58. I have 3.13, 3.29, 4.1, 3, and 5.94. Okay. So using Jefferson's, then our lower is going to be 4, 2, still 7, 3, 3, 4, 5, which the only one from the other lower, so lower, 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 those all match except for the only one that it helped was District 1. It did end up going up to 4. So that means we need to lower the standard divisor again. So we could lower it to 30. That would be an option. So if we lowered it to 30, the one that we're now trying to get to bump up would be the same ones that we end up getting in Hamilton's. We're really now trying to get 2 and 7. So I'm going to go over here and I'm going to try 2 is, if we do 30, that's going to be, it's still going to be at 2.96. So it won't round up. So if we do 29.5, then it does. So if we try a standard divisor of 29.5, then District 2 now has 3.02. And this one will still be 7.96. So we'll have 3.29, 3.5, 3.46. 4.34, and then this one will be 6.24. And then the first one will be 4.24. So then we will have our lowers would then be exactly what we want. 4, 3, 7, 3, 3, 4, and 6 with the Jefferson. So our standard divisor would be 29.5. Catch me back for another health video.